So when we say a model or a simple linear regression model, what the parameter we're focusing the most on is beta 1. Right? Beta 1 represents the relationship between the two variables, x and y. Okay. Now beta 1 could come in three forms. Right? Beta 1 could be positive, greater than 0. So that means there's a positive linear relationship going up this way. Or beta 1 could be negative. Right? Then that means it's a negative relationship. Or beta 1 could simply be 0. That means there is no linear relationship between x and y. Now, it should be clear that whenever we talk about relationship, we're talking about linear relationship. So let's say, for example, right, if I give you this scatter diagram of x and y, and you see that the x and y variable looks like this. Now the question is there a relationship? Of course there is. This is a parabola, and I can actually write the function of that, right? So the function of this could easily be, let's say, negative x minus 5 squared plus 12, right? So I'm just making up numbers, but I could describe this curve with the function. Therefore, there is a relationship. Now, if I do, however, if I do a linear regression on this, beta 1 would be 0. Right, the slope. Right, if I run a regression line, I try to fit a linear line between with all these data, then the line would be 0. Here we go. Beta 1 will equal 0. So even though there's obviously a relationship between the two variables, there is no linear relationship between the two variables. Whoops. No linear relation. And this is why it's so important to graph. Because if I don't look at the scatter diagram, if I simply just put the data in a computer, and then I ask the computer saying, "Oh, what is beta 1? What's the estimate of beta 1?" It's going to give me an estimate of 0. Right, and I might be mistakenly thinking that there is no relationship between x and y, where instead, right, where indeed there is a relationship. And so these are some of the things that the human mind is still good at, where we are good at picking out patterns. And so graphing, being able to graph data very quickly allow us to take advantage of our humans, of pattern recognition. All right. Now, so what we're interested in is this relationship, right? In the end, let me write that here. Here, where we are assuming that in reality, right, we have this phenomenon, right? That every observation, it is estimated, is created through this relationship, right? And so we would like to estimate that, right? So here is so the way we estimate is we want to estimate a simple linear regression equation. So the equation that we'd like to estimate is this: beta 0 plus beta 1 x I. So the parameters that we're trying to estimate, right, is beta 0 and beta 1. Okay, just like just like before, right, we're estimating mu, or we're estimating sigma, right, sigma square, right, basically the same idea. So our estimated simple linear regression equation, or we'll short call ESLRE, right, is going to be, right, y hat I equals b0 plus b1 x I, right, and and this would be an estimate of this equation, right? Y hat. So in statistics, anytime we put a hat on top, that means an estimation, and so we will use b0 and b1. That will be our estimate for beta 0 and beta 1. So b0 is an estimate for beta 0, and b1 is the estimate for beta 1. Okay. All right. Now, how will we go about doing this? Here's a nice diagram that I found in the textbook that can help with our intuition. All right. So here we assume our regression model, okay, and then our regression equation. And so here are the unknown parameters. So what do? We collect a sample data. Now, here is a sample data of n sample size, right? N sample size whoops, excuse me, and where each observation has two variables. Right? Because of every pair, or we call them ordered pairs, x1, y1, and then x2, y2, and then so on all the way down to xn, yn. Right? Every observation has two variables in it. Okay, and then we will estimate our regression equation. So we figure out what is the best way to we'll figure out to estimate b0 and b1. Okay, and then that will give us our estimate. So now, what is the best way to calculate our estimator? And there is no one right way. I really want to emphasize that there's no one right way. Right? There are many different ways we can estimate. It's just an estimate. It's like same thing as me, it's like asking, it's like asking somebody what the weather is. Right? There are different ways to estimate, to predict what the weather is. Right? Now, just because there's no one right way, but there is definitely one of the best way. Right? There are some ways that are better than others. Okay, and that's what we will explore.